All right, so there's some important equations that you need to be familiar with whenever we're connecting our hydrogen ion and hydroxide ion concentrations. So negative log of our hydrogen ion concentration is equal to our pH. But then, just as important as knowing this is basically knowing how to work this backwards. So going from a pH to a hydrogen ion concentration. I would say that being able to use this relationship, well, that helps you understand this relationship. And understanding that relationship combined with this right here, I mean, that kind of tells you all the foundational information that you need to know. So if the pH is this, what is the pOH? If the pOH is this, what is the pH of a solution? If you understand that, you're going to be in really good shape with this material. And you're definitely going to be in good shape for your homework. So this is like, don't play, this is not playing tricks on you or anything like that. All of these pieces of information are interconnected with one another. And I think that it's also helpful because whenever you know the pH of a solution, you can determine the hydrogen ion concentration. If you know the hydrogen ion concentration, you can figure out the pH. And so you have this mechanism, you have this way to do some calculations to confirm a number that you just solved for. So understanding this relationship is, or these relationships is going to be very helpful. Now, an example problem here, one that you might see on a homework or one that you might see on an exam, is what is the pH of a solution which has a concentration of hydroxide equal to 8.9 times 10 to the minus ninth? Okay, excuse me, I'm going to go ahead and say that there are lower hanging fruit problems than this. So, like, what is the pH of a solution if the pOH is 9? If the pOH is 9, then you know that the pH is 5. But this one is a step beyond that. What is that step? That step is negative log of 8.9 times 10 to the minus ninth. Okay, so I'll plug that into my calculator. 8.9 exponent negative 9 equals, that converts it from scientific notation. I'm going to plug in the log function and I'm going to get 8.05. That is my pOH. I think that one of the toughest parts about this is just remembering what you solve for. And then what's the question actually asking for? Well, as soon as we know that our pOH is 8.05, which if you look at it, that was one of our answer options, but we know that's not it. Okay, let's look at our other answer options. Answer option D, 14. Well, we know that can't be it because pOH plus pH equals 14. If our pOH is 8.05, then could our pH possibly be 7? No, because that would mean 8.05 plus 7 is 15. That can't be the case. So the only reasonable answer option is A, 5.95.